Hello everyone, myself Nathan from Mechanical Department and I am here to present an oral presentation on a topic robotics and role of a mechanical engineer in robotics. Let us see the topics for our presentation. What is robotics? Introduction to robots, history of robots, law of robots, is robots are necessary, 5D consideration of robots, types of robots, applications of robots, advantage and disadvantage of robots, role of a mechanical engineer. Let me move on to the first topic. First of all, what is robotics? Do you have any idea that what does a robotics mean? Just a simple idea. What would be a robotics be? Yes, robotics is a science of designing or building an application of robots. In other words, robotics may be simply defined as the study of robots. The main aim of robotics is to design an effective robot. Let us see the next topic. Introduction to robotics. Nowadays, robots have become a subject of great interest. In fact, robots are defined as the man made mechanical devices. Robots are also known as man made mechanical devices. In our imagination, a robot is a machine that looks and acts like a human being. Robots can move and do anything like us, and this activity should be controlled and monitored by us, and the behaviors can be influenced into robots by programming. By programming, the commands or the task what we have should be done should be programmed into a robot. Let me move on to the next topic, history of robots. Ben Sukara, an American inventor, he is known as father of robotics. The idea of automation originates in the methodologies of many cultures around the world. Many engineers and inventors from the ancient civilizations are trying to build a self-operating machine which resembles humans and animals. From the ancient time itself, many engineers and inventors are trying to build a self-operating machine which known as a robot which would resembles an human animals. I have attached the image of Ben Sukara with this invention robot. And then we move on to the next slide. The robot was first pronounced as robot, and then in late 50s it short with an U and pronounced as robot, but, and then in 60s it's softer with O and pronounced as robot, BOUGHT, and then in 70s it's once again pronounced as robot, BUT. In the year 1920, the term robot was first used in an RUR, Rosum Universal Robots. It's a science fiction play. It was first termed by an inventor called Isaac Asimov. He is Mr. Isaac Asimov who termed the word robot. Next, we are moving on to the next slide. In the year 1926, the first humanoid robot named as Helicoptero was invented by Televox. Later in the year 1939, this robot was developed and introduced in a New York World's Fair. The robot was 7 feet tall, so that is 2.1 meter, and weighing 250 pound, that would be 120.2 kg, and can speak up to 700 words using 78 RPM record player. So the robots can speak some 700 words using 78 RPM record player, and it can also move its head and arms, so it can rotate its heads and move up and down its arms, and it can blow up balloons and smoke cigarettes. The body of the robot consists of a steel gear, cam and a motor, and the skeleton is covered by an aluminum skin. This is the image of the robot Electro, that is pronounced as ELEKTRO. Moving on to the next slide. The first digitally operated and programmable robot was invented in the year 1954 by George Devol. The robot was ultimately known as Unimate. It was known as Unimate because this robot laid foundation for the modern and the future developing robots. He is Mr. George with his invention named as Unimate, and I have attached the image Unimate also separately here. And moving on to the next topic, laws of robots. As humans, we have certain laws and regulations to be followed. Similarly, robots too have some laws which is proposed by Isaac Asimov. As we said in the earlier slide, the term robot was introduced by Isaac Asimov. He is the man once again who's proposed the laws for the robots. The first law says a robot may not injure an human being or through inaction allow a human being to come to harm unless this would violate an higher order level. Second law states that a robot must obey orders given it by human beings except where such orders would conflict with higher order level. The third law states that a robot must protect its own existence as long such as protection does not conflict with other higher order law. Isaac also, after proposing these three laws, he later added another one law known as zeroth law. The zeroth law states that a robot may not injure humanity or through inaction allow humanity to come to harm. Moving on to the next topic, is robotics necessary? Before getting into the topic, do you think that robots are necessary for us? Yeah, robots are necessary for us in many ways. Let us see the ways in the next topic. Coming back to this topic, robots are necessary because it can do work with accuracy, it can do repetitive tasks, it can work in hazardous and dangerous places and temperatures where a human can't, and robots are widely used in manufacturing, assembly, and packing transport. Moving on to the next slide. Um, as I said in the earlier previous topic, robots are necessary in many different ways. These different ways are taken as 5D consideration for robots: dangerous, dirty, dull, dexterous, domestic. Let's first see dangerous. Diffusing bomb, mining, and space exploration. These are the places where the robots are used, because if humans are gone there, their lives are not given assurance for their lives. There's not given assurance, so robots can be used in that dangerous places. And dirty, spraying paints and blocking sewage and drainage pipe. Spraying paints, the toxic ones, affects our skin and health, so robots can be used. Dull, factor line works and heavy stocking jobs. If a man works more than 7 or 8 hours per day, he would become dull, and he can't work. But if a robot does that, it works with the same speed and an accuracy till the end without becoming tired. Textures, surgical jobs and nanobots. This dexterous the robot should be done with an high level of accuracy where the humans can't, so robots can be used in that places. And domestic, all household works comes under a domestic category. In the next slide, you can see the images for the previously discussed topic. So these are the images. So moving on to the next topic, types of robots. Robots are of five types: pre-programmable robot, humanoid robot, autonomous robot, teleoperated robot, augmenting robot. Moving on to the next topic, applications of robots. Robots are used to work together in many fields like robotic painting, robotic welding, robotic assembly, part transfer, and mission tending, etc. like that. Robotic painting makes works easy for professional painters to deal with the toxic ones, because it is very harmful to our skin and health. So robots can be used there in robotic painting. Robotic welding are used in automobile industries, and robotic assembly are used in automobile plants. Part transfer and mission tending are the major source of productivity. So let me move on to the next topic, advantages of robots. Robots are useful in many ways: safety, speed, perfection, etc. like that. First, let us see about safety. It's the most important advantage of utilizing robots, because robots are very much safely it will handle the things safely in its surroundings, and etc. So speed, robots do not get distracted and complete the work on or before the deadline, so it does not get distracted, or it does not get tired. It works with the same speed till the end. So it's an advantage for a robot. Then perfection, robots will do the work with accuracy. Robots can do the work with high level accuracy where a human can't. Robots are known as the happier employees in the sense they need not worry about the salary, and they do not get tired, or they do not take a break in the in between time, like that. So they are known as the happier employee. And robots can work longer hours than humans without even taking breaks. So as I said in the previous point, so let me move on to the next topic: disadvantages of robots. Many people can lose their jobs in factories, etc. It needs a supply of power. It needs proper and regular maintenance to keep the robot in a running condition. The cost of the robot is high. These are the disadvantages of robots. So moving on to the next topic, role of a mechanical engineer in robotics. As a mechanical engineer, I think that a mechanical engineer would work in an hardware compound or something like that. So they are mostly gonna work on the hardware compounds or to design the structure of a robot, joint mechanism, bearing and heat transfer, and they are gonna design the parts of a robot and work together to do what you need the robots to do. So let me move on to the next topic. Sorry, next slide. A big part of this is to design for manufacturing. To design the robots for manufacturing is a big deal. So you would also handle the strength, performance stimulation, such as FEA. FEA means finite element analysis. So you should handle the strength of performance stimulation and FEA, etc., like that. You would also likely to be one of the physical prototype testing as well. So you should test the physical hardware components to for the robots, whether it is suitable for the robot or not, something like that. So these are the roles of a mechanical engineer in robotics, to design the hardware components and something like that. And thank you for your patience. Thank you.